Hello and welcome to RMK Technology. This particular session is about Introduction to Advanced Metering Infrastructure. In this slide we have tried to define smart grid. Smart grid has many definitions. Main features of a smart metering should have intelligent monitoring of consumption, bidirectional data transmission, increased security of supply and higher efficiency, variable tariffs dependent on overall consumption and grid load. So basically in a smart metering solution both utility company and customer should be able to see hourly, daily, weekly and monthly consumption. Also in this system meters can be directly reached from the system for control of meters for remote connect or disconnect. Also since in this system meter reading can be available every 15 minutes or half an hour, tariff can be applied based on time of day. This slide depicts main components involved in smart metering solutions. Smart metering infrastructure comprises of smart meters, communication of data from smart meters to head-end systems. From this head-end system data goes to meter data management system and subsequent to of smart meter app. Other considerations like security and customer are also very vital. There are control devices like air conditioner control etc. that can also be linked to the network. These are called in-home devices. Security is very important for preventing any alien meters or devices being introduced in network to disrupt the system. This slide depicts what are benefit of smart metering solution. It provides detailed information on what is being consumed, delivered on a quasi-real-time basis. Supports in-home displays. Provides the data for consumers and utilities to make smart energy choices. Improves utility operations by, for example, identifying where energy is being consumed. Helps localize outages. Highlights areas with possible energy theft. Helps customers deliver energy to grid. Eliminates the need to change meters when services or features are modified, such as time of use. Provides a pathway to the smart grid. What we can do with smart metering applications. Below are few applications derived from available large chunk of data from AMI system. Monthly meter reading, total consumption, off-cycle meter reading, total consumption, monthly kW demand read, static time of use, for example, peak, off-peak, shoulder, real-time pricing, passive load control, curtailment or interruptible service, power quality monitoring, outage detection. This architect depicts how Field's devices are connected to various applications. Field's devices are connected to data communicating network through broadband or other means like LTE/4G or GPON. This slide depicts complete end-to-end system architecture. It starts with an AMI system called head-end systems. Data from different head-ends like energy ICT, Cuculus, Dial is RATnet combines together in system called Meter Data Unification System. SAP EDM is used in many places for MDUS system. This MDUS is connected to SAP through many MDUS connectors. This data in SAP is processed for many functionalities like master data management, periodic reading, on-demand reading, asset management, outage management etc. This slide depicts various communication channels used in smart metering solution. Field devices are connected to dedicated networks through wired or wireless communication. Radio meters are connected to remote data collectors which collects all the parameter coming from meters telegram. Telegram is the parameters that is set in meters which are need to be transferred application systems. These include values like different types of reading like kWh, kVAh, kW, meter temperature, battery life etc. This slide depicts various work stream involves in smart metering program. This is generally mega projects involving many work streams. Starting from metering infrastructure till IT infrastructure and back-end systems. Various work stream involvements in the smart metering projects can be listed as below. Technical infrastructure to be tested during project, supporting AMR capability. Collaborative model for client to gain support from regulatory frameworks. PMO to support the processes impacted by the AMR. Value proposition and benefit modeling to prove validity of the pilot. Efforts to increase customer adoption and benefits to client and its customers. Systems and integration architecture required to support AMR capabilities. This slide depicts the event processing in SAP. The event gathered through AMI infrastructure can be more systematically processed in SAP using SAP PI, BRF Plus and SAP CRM. Rule sets can be defined for each and every type of events. Predefined actions are linked to each type of event and then follow-up actions are defined and executed. The action required and action taken then can be passed on to various systems including CRM and even back metadata unification system. In MDUS system, event status management is required to track on the events. This slide again attempts to define advanced metering infrastructure and its benefits. Advanced metering infrastructure, AMI, is a comprehensive, integrated collection of devices, networks, computer systems, protocols and organizational processes dedicated to bidirectionally distributing highly accurate information about customer electricity, water and/or gas usage throughout the utility and back to the customers themselves. Various capabilities of AMI can be listed down below. Record customer consumption and meter event information hourly or more frequently. Remote disconnection and reconnection. Outage detection. Quality of supplies monitoring. Demand limiting. Communication interface to in-house displays, direct load control. Equipment etc. This slide again listing down main systems involvement in AMI architecture. It starts with AMI head-end system at the start to capture meters data and pass on to MDUS system, which does consolidation, unification, validation and estimation as per rules predefined. It is important at this point to define few business use cases which are prime drive to have AMI infrastructure at first place. Master data synchronization. Periodic reading. On-demand reading. Remote connect. Remote disconnect. Event handling etc. This slide shows how technical and commercial systems are integrated. Left-hand side of the slide show two metering chain of AMI infrastructure. There are meters which transmit data to concentrators. Meter to concentrator data transfer can be through wired mode or wireless mode. From these concentrators data passed on to head-end system which in turn pass it to MDUS system. MDUS is vital system as it prepare data for business use. It makes sure that various keys are properly assigned and linking between meters to customer is properly assigned. How customer should make themselves engaged. This is most important aspects as customer engagement ensure maximum benefit out of AMI setup. As for the cost estimates, we are not just talking millions but it is in billions dollar. So what are various stakeholders involved in AMI? Just for example, following are mandatory. Consumer engagement and demand response. Planning and AMI installation management. Meter to cash, meter data management. Meter to cash, customer operations and billing. Operations, AMI operations. Operations, distribution and planning. This slide puts some definition to AMI and MDUS systems. AMI system or AMS. Advanced metering system, collects data from the meters and communicates the commands from the MDUS to the meters. There can be several AMI systems, 1, N, in an AMI scenario, each one catering for a set of meters. MDM, MDUS, Meter Data Management, Meter Data Unification and Synchronization System, is the central system which communicates with the AMS and the back-office components. It stores all the meter data collected from different AMS and processes it as required by the back-office applications. It also triggers commands and events as required by the business to the meters through AMS. SAP AMI was introduced from EHP4 onwards to ECC6 as an extension to SAP ISU. So what were changes to ISU? Mainly 3 modules have seen changes due to AMI. Device management, meter reading and customer services. SAP also developed a large number of AMI enterprise services for communication with MDUS systems. This slide depicts the interfacing of MDUS system with SAP ISU. This slide represents the workflow for technical master data exchange. Process start with creation of device in SAP ISU. This create device in ISU trigger a request for device replication in MDUS. Once device creation is successful in MDUS, it send confirmation of device creation back to SAP ISU. MDUS system will assign ISU device with in-field AMI device. This generally happens through multiple keys mapping. This slide explains in details. Within the technical master data exchange process, a new device is created within ISU. After the creation, basic technical device data are sent to the AMI system via middleware containing device identification data, for example serial number. With the help of these data, a dummy device is created within AMI. When registering physically the new device to the AMI system technical device identification criteria, from the ISU, are assigned to AMI internal device identification criteria. At this time, a notification is sent optionally from the AMI to ISU telling that the registration and identification of the meter was successful. This slide describes changes introduced to meter reading document as part of SAP AMI enhancement. MRD have new values like advanced metering system, transmission status and transmission date and time. The process of meter reading order creation can be summarized as follows. Creation of MR order. Send XML message. MRO status is updated. Trigger for meter reading result can be from SAP or from AMS system. The subsequent procedures for SAP and AMS are different. When triggered from SAP, meter reading result is stored and status of meter reading document is updated. When pushed from AMS, meter reading order is created and confirmation is sent to AMS. Also for on-demand reading, it can be triggered from SAP. There are few other changes in meter reading screens, mainly in below area. Enhancement of monitoring for meter reading results, cancellation of meter reading orders, general enhancements for transactions using MR results. This screen describes the evolution of AMI from AMI 1.0 to AMI 3.0. AMI 1.0 was basic with meter reading both periodic and on-demand, master data management and disconnection/reconnection. Also a large number of enterprise services was created. In AMI 2.0 focus was on energy data management. Integration with MDUS system is also enhanced in this version. AMI 3. Main focus is on event management. CRM integration is also enhanced. Market communication for deregulated market is also introduced. Future focus is on analytics. This is very important to match the device ID starting from field till application systems. There are so many devices in the customer premise, in network, in communication, etc. All these has to be uniquely identified in all the systems. Keys should be properly assigned. This slide is showing how field devices are identified with unique keys starting from meter and its register ID to data concentrators to host controller. These ID are referred even in business processes like work order system, customer information system, GIS and asset management system. This slide depicts the importance of systems in the whole value chain of AMI system. It is important to know effect of smart grid on the normal day-to-day activity of utility. Smart grid enables several new customer services like solar power, wind energy, plug-in hybrid vehicle. Data services becomes essential in smart grid as data become backbone to all customer services. So what are technological challenges? Smart grid through open multiple technical challenges as it involves multiple systems. Data warehouse can be used for meter reading archiving. Data synchronization is vital as multiple databases are used in multiple applications. Security is key as almost entire network control is available through one or other application. There are multiple automated customer and in-house services like portals and mobile applications. A large utility company has multiple head-end systems and multiple communication systems. This slide shows one of use case of high bill investigations. The read from AMI is used to analyze, eliminate, balance and couple. It can be used for track potential high bill calls, eliminate estimate, adjust meter reading and verify if high usage impacts performance. AMI lead to new customer service experience. It gives user a control over usage of utility services. In this regards, utility customer service activity also turned into a help desk, helping customer choose the usage pattern for best saving. IT skills become imperative for the workforce. This slide depicts functions that can be used in AMI system. Active, reactive energy, net metering, tariffs, remote disconnect, load profile, prepayment, tamper, fraud detection. This slide shows how one end-to-end smart grid vision looks like. It is vision of New Zealand connecting every stakeholders of utility into one network including retailers, distributors, transmission with systems including back office, GIS, AMI and ERP. This concludes the introduction of AMI session. We have seen in details what is AMI system and how it affects utility system. In individual sessions we will see details of AMI solution including security, systems and applications. Thank you for your attention. For more details please visit at www.rmktechnology.com.